Mirrors. They're obviously multicolored, aren't they? But then, why is silver used to make mirrors? Since they reflect back all wavelengths of light, shouldn't they be white? Are they silver or are they white? Are they the color that you shine on them, or are they green? The color of an object is associated with the color or wavelengths of the photons that reach our eyes from the object, whether the photons are reflected or emitted by the objects themselves. Detailed videos can be found in this playlist of videos. To understand the color of a mirror better, we would have to understand what makes a mirror a mirror. When light bounces off of an object, the light can undergo specular or diffuse type of reflections. Specular reflections occur when parallel rays are reflected back as parallel rays, while diffuse reflections occur when parallel rays refrain from being parallel after reflection. Based off of Snell's law for reflection, the angle of incidence should always be equal to the angle of reflection, which means this angle should always be equal to this one, which makes it seem like diffuse reflections are violating this law. However, if you zoom into the surface of most objects, they aren't smooth, which means that Snell's law still holds at the microscopic level for every individual ray. However, this is usually an oversimplified explanation for diffuse reflections that is taught at a school level. In reality, most diffuse reflections occur due to the property of the material itself, irrespective of how smooth the surface is. This is because objects are made up of domains or layers like this. When light hits the surface, it actually passes through a few layers, gets absorbed, and then re-emitted. This is why, when various wavelengths of light are reflected off of a white wall, the rays are technically mixed during their irregular reflections, and hence our eyes see it to be white. This is what causes diffuse reflections, and we will have another dedicated video to it soon. However, in the case of a mirror, metals such as aluminum, silver, platinum, light does not get absorbed and re-emitted like the others. Here, light directly gets reflected off the surface, so it is necessary for a perfect polished finish for reflections to occur properly without distortions. So we can conclude that mirrors are not exactly white, because white occurs with diffuse reflections, while mirrors have specular reflections, and so the colors won't mix during the reflection process. However, if we were to take a metal like silver and roughen the surface to mimic diffuse reflections, we still do not see white. We see what we call a silver color, which is a type of light gray. If you watch this PhysiFacts video, you can guess the reason for this phenomenon. Even in case of metals, when light is reflected, not 100% of the light will be reflected back. Some of the light is absorbed and then used in heating up the metal. This actually causes fewer photons to be reflected back than the actual number that is falling on it. Due to this, we see less white, which is just gray or silver. If all the photons were absorbed, we would be seeing black. So a darker metal would be so simply because it absorbs more light. That's also why they get heated up faster. We can conclude that mirrors are not silver, as silver is the color we would get if the mirror was no longer smooth, and hence no longer a mirror. The next argument could be made that mirrors are just whatever color you choose to flash onto them. Place an orange cloth in front of the mirror, and the mirror becomes orange. However, as discussed, not all the photons of light are reflected back, and the amount by which these photons are absorbed is not equal for different colors. Therefore, we could actually state that mirrors are whichever color is reflected back the best compared to all the other colors. Most modern mirrors use a layer of glass above the silver coating. This glass is generally where most of the loss of light occurs. Most glass used actually absorbs green the least, and hence green is reflected back the best. This is why mirror tunnels, which are made with two mirrors facing each other, do not go all the way to infinity, and not only fades away after a point, but also the reflections get greener and greener as you look further into the tunnel. So most mirrors are actually green. Technically, they are whatever color is reflected onto them, just with a little added greenish tint. If you were to have a mirror from a perfectly polished metal only, it would be a slightly darker version of whatever color you shine on it. However, in case of colored metals like gold, the reflections have a golden tint, and this is actually due to Einstein's theory of relativity, and that's in store for a future video. So, to quickly conclude, mirrors reflect light very different from most other objects, but all objects do reflect light. Mirror-like reflections are called specular reflections, and parallel incident rays remain parallel after reflection. Mirrors are not white unless they're reflecting something already white, because looking white requires diffuse reflections. They're not silver because to appear silvery, they need a rough surface, making them no longer mirrors. Most mirrors have a glass slab that absorbs green the least, so most mirrors add an almost unnoticeable green tint to whatever is reflected in the mirror. Finally, a mirror made up of just a pure, perfectly polished metal would be a darker shade of whatever color it's reflecting. Thank you so much for reflecting upon the various concepts dealt with in this video. The future videos in this series will explain the quantum mechanics of diffuse reflections, the relationship of general relativity and gold, and also why the Earth twinkles from space. So stay tuned by subscribing. Don't forget to share this video and comment down your favorite application of mirrors, and don't forget to follow PhysiFacts on Instagram to get a daily dose of tiny facts. Till then, stay safe, stay curious, and keep learning.